Hello my Linians, this is Teacher Sarah, and today we are going to discuss functions. This video tutorial is based from your learning activity sheets in General Mathematics, Quarter 1, Week 1. So, bring out your learning activity sheet and turn your learner's module from page 1 to page 20. Are represents real-life situations using functions, including piecewise functions. Evaluates a function. Performs addition, subtraction, multiplication, division, and composition of functions. And solves problems involving functions. Before the lesson, let us have some warm-up questions. I have some questions for you to answer. The given set of ordered pair as shown below, what do you call the first number in the given ordered pair? Time starts now. Great job! What do you call the second number in the given ordered pair? Time starts now. Okay, the answer is range. Great job! What is relation in mathematics? Time starts now. A relation is a set of ordered pairs. Great job! Let's talk about the difference between relations and functions. The table below shows the differences between relations and functions. Relation is a rule that relates values from a set of values called the domain to a set of values called the range, while a function is a relation where its element in the domain is related to only one value in the range by some rule. Relation is the element of the domain can be imagined as input to a machine that applies a rule to these inputs to generate one or more outputs, while function is the elements of the domain can be imagined as input to a machine that applies a rule so that its input corresponds to only one output. A relation is also a set of ordered pairs, xy, while a function is a set of ordered pairs xy such that no two ordered pairs have the same x value but different y values. Example of functions. Money as a function of time. You never have more than one amount of money at any time because you can always add everything to give one total amount. By understanding how your money changes over time, you can plan to spend your money sensibly. Businesses find it very useful to plot the graph of their money over time so that they can see when they are spending too much. Location as a function of time. You can never be in two places at the same time. If you were to plot the graph of where two people are as a function of time, the place where the lines cross means that the two people meet each other at that time. This idea is used in logistics, an area of mathematics that tries to plan where people and items are for businesses. There are ways of expressing functions. Okay, by ordered pairs. From the example below, f and h are functions because there is no two ordered pair have the same x value, while g is not a function because 1, 3 and 1, 4 have the same x value also in 2, 5 and 2, 6. A function is a set of ordered pairs xy such that no two ordered pairs have the same x value but different y values. Using functional notation, we can write f of x equals y, read as f of x is equal to y. In particular, if 1, 2 is an ordered pair associated with the function f, then we say that f of 1 equals 2. By table of values, in example letter A, 1, 2 is an element of f. We can use the notation f of 1 equals 2. In general, can use the notation f of x equals y for its ordered pair, xy, in f. We can also organize this ordered pair as a table. The function a can be represented by the table of values below. So we have input, our x. We have a set of values, the first number, 1, 2, 3, and 4. And for our output, represents y, we have 2, 2, 5, 5. Another way of expressing function is by mapping diagram. It may also be used to represent the ordered pairs in relation or function. In this case, the relation or function is represented by the set of all the connections represented by the arrows. Which of the following diagrams represents a function? Choice 1 or choice 2? Okay, very good. The correct answer is choice 1. Which mapping represents a function? A or B? What do you think is the answer? Okay, very good. The answer is letter B, because its domain corresponds to only one range. Another way of expressing function is by graph. There is an instrument or device used to determine if the given relation is a function, and this is a vertical line test. A relation is a function if a vertical line drawn through its graph passes through only one point. It is also known as the pencil test. You take a pencil and you move it from left to right or from negative x to positive x of the Cartesian plane. If it crosses more than one point, it is not a function. Observe the movement of pencil in the given graph. So when a pencil moves vertically and it intersects the graph at only one point, a relation is function. First graph is a function while the second graph is not, because the pencil intersects the graph at more than one point. Which of the following graphs represents function? A, C, and D are functions because when you draw a vertical line, intersect the graph at only one point. Another way of expressing function is by description or by sentence. Which situation represents a function? A, the items in a store to their prices on a certain date. B, types of fruits to their colors. What do you think is the answer? Yes, the correct answer is Letter A. There is only one price for its different items on a certain date. The relation from items to price makes it a function. A fruit such as an apple from the domain will be associated with more than one color, such as red and green. The relation from types of fruits to their colors is not a function. So to sum it up, the different ways in expressing functions are functions as a machine, ordered pair, table of values, mapping diagram, graph, description or sentence, and additional is by equation. So in our next topic, I will show you the use of equation to determine if a relation is function or not. Piecewise functions. Some functions can only be described by more than one formula, depending on the value of the independent variable. Example, a user is charged 300 monthly for a particular mobile plan, which includes 100 free text messages. Messages in excess of 100 are charged 1 peso each. Represent the monthly cost for the text messaging using the function T of M, where M is the amount of messages sent in a month. Solution. The cost of text messaging can be expressed by the piecewise function. T of M equals 300 if 0 less than M less than 4. T of M equals 300 plus M if M is greater than 100. Evaluating function. So what is evaluating function mean? Evaluating function means replacing the variable in the function, in this case x, with a value from the function's domain and computing for the result. To denote that we are evaluating f at a for some a in the domain of f, we write f of a. Example, if f of x equals x plus 8, evaluate its a. f of 4, b. f of negative 2, c. f of negative x, and d. f of quantity x plus 8. So all you have to do is to replace each value of x in the given function f of x equals x plus 8. Solutions in the above examples. Our given is f of x equals x plus 8. For letter A, f of 4, you replace 4 to x, it becomes 4 plus 8, or f of 4 equals 12. F of negative 2, you replace negative 2 to x plus 8, or 6. F of negative x, you replace negative x to x plus 8. So finally, your f of negative x equals negative x plus 8. And for D, f of quantity x plus 3. So you replace quantity x plus 3 to x plus 8, or f of x plus 3 equals x plus 8. Another example, the price function p of x equals 640 minus 0.2 times x represents the price for which you can sell x printed t-shirts. What must be the price of the shirt for the first 3 entries in the table? Solution. From the given equation in the problem, to find the price per t-shirts, we have P of X equals 640 minus 0.20x. If the target number of sales t-shirt is 500, just replace it in the given equation. Replace 500 to X. The price per t-shirt is 540. If X is 900, the price per t-shirt is 460. If X is 1,300, the price per t-shirt is 380. If X is 1,700, the price per t-shirt is 340. If X is 2,100, the price per t-shirt is 220. And if X is 2,500, the price per t-shirt is 140. Okay, so let's put the computed value for price per t-shirt in the table and you observe. So what is the relation of X to Y? Good. As the number of sales t-shirt increases, the price per t-shirt decreases. Next, let's tackle about operations of function. In operation of function, it is the same in operation of numbers. So these are addition, subtraction, multiplication, and division. So for operation of functions, we have also addition of function, subtraction of function, multiplication, division, and composition of function. For addition of function, you let f and g be any two functions. The sum f plus g is a function whose domains are the set of all real numbers common to the domain of f and g and defined as follows. F plus g of x equals f of x plus g of x. And for subtraction of function, you let f and g be any two function. The difference, f minus g, is a function whose domains are the set of all real numbers common to the domain of f and g and defined as follows. F minus g of x equals f of x minus g of x. When we look at function, we also want to look at their domains, valid x values. In this case, the domain is all real numbers. For addition of function, let us have an example. You let f of x equals 3x plus 8 and g of x equals 2x minus 12. So these are the given function. By definition of addition of function, f plus g of x equals f of x plus g of x. F of x is 3x plus 8 plus g of x is 2x minus 12. By combining like term, we have 5x minus 4. So therefore, f plus g of x equals 5x minus 4. So let us have finding the difference. Let us use same function. By definition, f minus g of x equals f of x minus g of x. F of x is 3x plus 8 minus g of x is 2x minus 12. So you put a parenthesis symbol for g of x or for our subtrahend. That is very important because we following a rule that if the sign is negative preceded by a parenthesis, you may change the sign of the numbers in the given parenthesis. So we have 3x minus 2x is x, then positive 8 minus negative 12. So negative 12, you change the sign, this becomes positive. Therefore, positive 8 plus 12 is 20. So our f minus g of x equals x plus 20. When we look at values, we also want to look at their domains, the x values. In this case, the domain is all real numbers. Then how to multiply function? In multiplying function or in finding the product, it is denoted by f.g. That means multiplication is the function denoted by f times g of x equals f of x times g of x. So let's have an example of function. Let f of x equals x squared minus 1 and g of x equals x plus 1. Find f times g of x. So by definition, equals f of x times g of x. F of x is equal to quantity x squared minus 1 times g of x is quantity x plus 1. So observe, so this is multiplication. So by observing, you may find the product by distributive property or by FOIL method. So any method you want to apply, it's up to you. So by distributive property, we have x cubed plus x squared minus x minus 1. So there is no similar term. That's why this is your final answer, that your f times g of x equals x cubed plus x squared minus x minus 1. In this case, the domain is all real numbers because there are no values that will make the function invalid. In finding quotient or in division of function, by definition, f over g of x equals f of x over g of x. So let's have an example. Let us use the same function given in multiplying function. F of x equals x squared minus 1 and g of x equals x plus 1. So you replace f of x by x squared minus 1 and g of x is x plus 1. You observe that the numerator is factorable. So that is a perfect square binomial. So by factoring, this becomes x minus 1 times x plus 1 divided by x plus 1. So you may cancel the same numerator and the denominator. So canceled out quantity x plus 1 in the numerator and in the denominator. So finally, our f over g of x equals x minus 1. So in this case, the domain is all real numbers except negative 1 because x equals negative 1 will give a 0 in the denominator. And the last operations of function is the composition of functions. Composition of functions is the successive application of the functions in a specific order. Given two functions f and g, the composite function f open dot g is defined by f composed of g of x equals f of g of x and is read as f of g of x. The domain of f composed of g is the set of elements x in the domain of g such that g of x is the domain of f. Example, f of x equals x minus 3 and g of x equals 2x squared minus 1. Find f composed of g of x and g composed of f of x. F composed of g of x equals f of g of x, meaning to say the domain of f is g of x. So doing that example, your f is x minus 3, but the domain of f is g of x. So our f of x, x minus 3, becomes 2x squared minus 1. You replace it to x minus 3. Then, combining like terms, your f composed of g of x equals 2x squared minus 4. And for g composed of f of x, by definition, it is equal to g of f of x. This time, the function of g or the domain of g is f of x. So our g is 2x squared minus 1. So we have to multiply by x minus 3 to the second power minus 1. To simplify, so first find the product of quantity x minus 3 squared, and that is x squared minus 3x plus 1 times 2 minus 1. And then by distributive property, you distribute 2 in the whole quantity inside the parenthesis. So we have 2x squared minus 12x plus 18 minus 1. Then continue simplifying. We have 2x squared minus 12x plus 17. So finally, your g composed of f of x equals 2x squared minus 12x plus 17. Example number 2. Our given functions are g of x equals x raised to negative 1 and h of x equals 2x to the third power. Find h composed of g of x and g composed of h of x. So by definition, h composed of g of x equals h of g of x. g of x is the domain of h, where our h is h of x equals 2x to the third power. Therefore, 2 multiplied by x raised to negative 1 to the third power. As you observe, so we have x raised to negative 1, then raised to the third power. From the law of exponent, you are going to multiply their exponent. If you multiply them, negative 1 times 3 becomes negative 3. So therefore, this becomes 2 times x raised to negative 3. And to make your exponent positive, so you are going to put this in the denominator to simplify. So we have x raised to negative 3, then if it is located in the numerator, so to simplify or to make your exponent positive, you put it in the denominator. Therefore, this becomes 2 over x to the third power. So therefore, h composed of g of x equals 2 over x to the third. And for g composed of h of x, by definition again, equals g of h of x. Again, h of x is the domain of g. Our g is x raised to negative 1. So therefore, this becomes 2x to the third power raised to negative 1. Again, from the law of exponent, so the exponent is negative, so you are going to put it in the denominator so that our g composed of h of x equals 1 over 2x to the third power. So that's the end of operations of functions. At this point, you turn your activity sheets to do your task. Reminder, do not write anything on this activity sheet. Write your answer on a separate long bond paper. For enrichment activity 1, determine the following relations represent a function. For enrichment activity 2, evaluate each function at the indicated values of the independent variable and simplify the result. For enrichment activity 3, given the functions, you are going to apply your knowledge in operation of function. For enrichment activity 4, given the functions, you may apply your knowledge in composition of function. I hope you learned something today. If you have questions or clarifications regarding the topic we discussed, feel free to contact your subject teacher through text, call, or post your questions in your official Facebook group or page. Thank you for watching. Don't forget to like and subscribe. Bye-bye!